What's up, guys? It's Ian and Jillian here, back with another math video, and today's subject is vectors.
The definition of a vector is a quantity having as well as magnitude, especially as determining the position of one point in space.
Vectors are most commonly taught in geometry when finding the sides of a triangle and in physics when referring to magnitude and direction. Below are some examples. Creators of vectors. Josiah Willard Gibbs, the creator of vectors we know and love today. He was born in New Haven, Connecticut, and raised by his dad, who was a professor at Yale. Gibbs is mainly known for his achievements in the thermodynamics and later in vectors. Gibbs was introduced into vectors by James Clerk Maxwell and found vectors would be more efficient for his line of work. He later wrote his first book on modern vector analysis. Gibbs assembled all of his notes to compile Vector Analysis in 1901.
The jobs that are most commonly used amongst vectors are nuclear engineers, civil engineers, real estate agents who use vectors to monitor rises in price in houses, physicians and surgeons, and sports such as basketball, football, and golf. Those are used most commonly when referring to the slope of throwing, kicking, or hitting the ball. In the real world. Our problem is a golf ball is hit 35 miles, 50 degrees north of due east. Find the magnitude of the vertical and horizontal factors. Here, 35 is seen as the miles and 50 as the degrees. In order to solve for the magnitude of x and y, cosine and sine must be used.
Magnitude of x, cosine 50 equals x divided by 35. Steps are 1. Multiplying both sides to get x by itself, leaving us with cosine 50 times 35 equals x. 2. Solve cosine 50 is 0.64 times 35 equals x. And lastly, multiplying to solve, and x equals 22.49.
To solve the magnitude of y, you have sine 50 equals x divided by 35. And in order to do this, you have to take the steps of 1, multiply both sides to get x by itself, so sine 50 times 35 equals x. 2, solve sine 50, which equals 0.76, times 35 to equal x, and multiply to solve, which you get x equals 26.81.
To finish off our lesson today, we wanted to say we chose vectors because we initially learned it in geometry and were curious how it applied to the real world.
We deepened our understanding by studying more the historical background of vectors and how were they made and by who, as well as understanding how vectors can be applied in the real world within jobs and other problems.